want to introduce Alicia Kostecki and Jeanette Simenson from Walt Disney Magnet School. And the agenda today is actually effectively implementing CS algebra includes discussing mathematical concepts, programming games with algebra for students, reviewing the use of instructional videos, sharing effective implementation strategies, participating in professional development, and of course, setting up a class in Code Studio. And then we'll have a Q&A towards the end. And then I want to note that CS and Algebra Bootstrap webinars, this does not take the place of the CS4All required online summer or semester CS and Algebra training for teachers in cohorts 1, 2, and 3. This CS and Algebra webinar is intended to provide an overview, not training for integrating into classroom instruction, curriculum planning, and instruction. So again, it does not take the place of any online summer or semester CS and Algebra training. So with that said, I'd like to actually turn it over to our facilitators for this webinar. And so I'm going to turn it over to Alicia and Jeanette. You want to take it away?
Thank you, Charnel. Hello, everyone. So Alicia and I are coming to you from Walt Disney Magnet School, which was a cohort 1 school, started a couple of years ago. And Alicia was a part of that initial cohort. I joined this year as a kind of leading the CS and Algebra bootstrap here at the school. So I don't know if Alicia wants to add in anything about the cohort 1 kind of joining or where you guys started from, but we kind of have looked at computer science here at Walt Disney across the pre-K through 8th grade. And when I came on board in October, I had come off of training in CS4Algebra over the summer and had really connected with that because I was a former math teacher. And I noticed that we were doing quite a bit of work across the, like I said, the K to 8 in the different kind of areas of the courses of 1, 2, 3, and 4. But we really weren't in depth with CS and Algebra. And so it was a nice platform to jump from with them had already been on code.org. But what I was excited to do was really see a tangible way to apply our mathematical concepts to the idea of programming. So we really started an initiative somewhere around November in pushing into classrooms. And you can see some of the key points here that I thought were important when I first started here was, as a middle school math teacher, kids did not want to fix their mistakes. If 10 did not equal 12, they were like, oh, I just got it wrong, and they moved away from it. And I really wanted them to embrace those challenges, to go back and see if they could fix their problems, maybe turn to a friend, see if they could follow the directions or go through sequencing a bit more, and to get to that end goal. And so in looking at the code.org curriculum guide, which I'm going to click on for a moment here, you can see that the layout that code.org has provided is laid out in 2 courses, one that provides students with foundational skills, and then one that moves a little bit more into that in-depth kind of Booleans and things like that. And if you don't know what that is, you'll learn that this summer. But really that alignment to standards was a key component for me coming in as a math teacher. So just know that that's here. You all will be getting a copy of this presentation. And you'll be able to click and go to this part, and you can see all the different things about the CS and Algebra. So, in moving on, the mathematical concepts piece, I liked the way that CS and Algebra is laid out because it was very much laid out similar to how I taught math classes. We would have an overview, we would have some objectives, we would really kind of walk through any new learnings, and then, you know, piggyback that with an activity. And so again, with this link here, you can see that we do have that alignment. In each lesson, you can connect the Common Core math and then the practices, but also the computer science standards. So no matter what you're trying to hit on, you know, if you know that you're going to be going through and teaching simple expressions, or, you know, talking about graphing mathematical problems, you know that lesson 1 is something that can align with that. So this is laid out very nicely, and every lesson has that, you'll see on this page. The anchor standards, as I just mentioned, really kind of gave me when I stepped into the first class and taught it, I wanted to know what they knew and what they did not know. And I really started with the real world mathematical problem solving. And I came in and I supplemented with what they were doing in math. And fortunately enough, I came in at a time where they were doing slope. So it was a perfect opportunity to say, okay, this is what you were just learning in slope. Now we're going to connect it to this anchor standard that we're going to, propose in CS4 Algebra. So if you are, first time cohort 3, or if you've been doing this for a while, I tend to go back and really reevaluate what the math teacher is doing in alignment with what I'm doing and pushing in with the code.org lesson plans. So you can click on this standard as well. If you click here, again, most of these are all active links. And you can see the framework, again, laid out in a really simplistic form of the overview, the objectives, and the standards. So, if you're coming to this for the first time and you're going to go into the summer training, some of these links I'm providing for you are really nice to see and know that they're there, and they're going to be very useful to you when you get into the summer training, because that's where you're going to kind of think, well, how would I align this to what I have currently going on in my school? The best part about code.org, I think, is the instructional videos. And this ties into whether you're a believer in flipped learning, you're a believer in giving students videos that will help move their learning along at their pace. The video library that code.org provides is extensive, and it really does connect quite extensively when you talk about algebra. So you can see here, why is algebra so hard? The modeling and coordinates, the coordinate plane. We come back to order of operations, domain and range. So all of these are popping up throughout our entire middle school math. And then we start getting into, like I said, that second half, that part B, we start getting into things like the design recipe and Boolean logic, which is more computer science based, but again, we're still really enforcing overcoming challenges, trying to figure out how you're going to, fix your mistakes, working in partnerships to fix those mistakes. And there you end up with the Pythagorean theorem as well. So use those videos, whether it be as a tool to show whole class, or as students are moving along, you're encouraging them to look at it. I used to put these videos up on a Google Classroom and ensure that the students were not just skipping over it. Because when you open up the code.org activities, they can just X out of the videos. And I noticed they were doing that a lot.
Yes, they definitely do.
Yeah. So I would almost stop them and, stop and ask questions, do it as a whole class.
Yeah, I've usually done the instructional videos as a whole class. I find that to be, I can tell who's watching it.
Mm-hmm.
So that's very helpful.
Yeah, I would think maybe you could even do like a Google form or something afterwards, quiz them, a little feedback. But
and I find myself coming back to them. I don't just watch them once. We'll usually go back and watch them again.
And also take note that after they finish an activity, and if they get it wrong, or maybe they need to go back and do something, code.org does a good job of saying, hey, you should probably watch this video to kind of help you with hints and instructions. So you want to make sure that students and know that that's an option for them. This is probably the most important part of what Alicia and I believe is very strong with computer science and math and everything else that is great with education, is that this use of pair programming. And Alicia's going to talk a little bit about our driver navigator.
Yeah, in pair programming, students are partnered. And I have found that often we think that students know how to work together, but they don't, and they need some guidance and some structure for working together. So this video shows, is a great video. I've shown it repeatedly, again, like showing these videos more than once because kids forget. But it describes the roles that they should take. One is a driver, and they're the ones that are actually using the computer, touching the keyboard and the mouse. And then there's a person who's a navigator, and they're there to help guide, help remind the driver what they're supposed to be doing. And very importantly, they often switch. So it's not that one person's a driver for more than maybe 20 minutes, and then they'll switch. I found that extremely helpful. It's also nice that they have each other because, as you know, we are one person in the midst of 32 other students. So having them there to help each other, ask 3 and then me, but, start by asking your partner, like really letting them struggle, I think is an important part of this.
Yeah.
So they have each other in that struggle.
Yeah. And piggybacking off that struggle, when you take the summer training, you as a teacher may struggle through computer science. Myself, Alicia, none of us were trained as computer scientists. And I think it was a really nice thing for me to go through it and struggle and fail and get frustrated. And you learn strategies. I had to get up and walk out of the room once to go to the restroom, or to get a drink of water, because you do need to kind of, give students those opportunities to fail and see what gets them through it. I think those are really important tools. So spend a lot of time, in this area talking about it. It may not seem math or computer science related, but it certainly is a tool. And then this is another area that tends to kind of get skipped over by teachers, but I think it's probably the most essential part of connecting not only to math, but also just connecting computer science to thinking. When you're talking about how do I, critically think through things, when you get them off the computer, sometimes it really can, have them think about puzzles or different ways. I don't know how many of us grew up with Rubik's cubes, but just
those are popular.
Yeah, I mean, just having that ability to kind of look at something and see if there's an evaluation there. So order of operations was always something as a 7th grade math teacher I was surprised that I had to cover over and over again, even though my dear Aunt Sally, please excuse her, they still did not know that worked. And so this was a nice, in stage 2, they offer an opportunity to look at how does it look like in code.org. There's different evaluation blocks, and this is what it looks like. And then this is what it looks like in real math terms. And so really reinforcing that this can be used for, obviously reinforcement or just to kind of go back and see where they're at. So to kind of move quickly through the math portion of this and into the computer science, I want to wrap up with talking about the alignment to the Common Core, as I showed you in a couple of the links. Here's a couple pictures, and these are just built in the lesson plans. It talks about what's a function, and really getting the idea of domain, range, function, vocabulary, and what does it look like? What does it do when you program it? How does that language kind of translate into something that I can actually see happen? And this is a really nice lesson because you do take the name, domain, and range, and you produce something from it with the uses of a contract. And also the coordinate plane. I think Alicia will talk a little bit in a second about other ways that we use computer programming here, but that use of the coordinate plane is how we move, for instance, this little dragon will move along this timeline. And so they need to understand that there's measurements involved and what does it mean to go up and down and move quadrants. And that slope actually isn't something that we just need to know the formula for, but it does, make things happen. There's talk about translations and transformations, measurement. So you're really hitting on all of the aspects of the math lessons that we're trying to hit on. So now we're kind of jumping into the actual bare bones of computer science and algebra from a code.org standpoint. These are all variables. These are numbers, strings, and images. And strings are just another way to make variables. They can be dependent or independent of each other. In this case, right now, they're independent. A number can stand for whatever number you want it to. A string can mean, in this case, it's going to mean a style or a color, but it could mean anything you wanted it to. Radius just happens to be a number. So you're going to input these variables and produce the output, which is the purple, the star, as we've called it here. And so getting kids to really understand that the A's, the B's, the X's, the Y's stand for something. They stand for a radius, a style, a color, or an image, such as a star. And it's nice that it's color-coded. It's almost fail-proof, in some ways, especially if you point that out. Look, blue matches blue and green matches green. So then the activity takes you one step further, where you are introducing, we just want to produce, a 50 pixel, in this case, solid red triangle. And in their workspace, they're going to produce this, and then they're going to press run, and, up pops a solid red triangle. And so they immediately see what they've put in variables, and then they might play around with those variables. They might put in 100 and see how much exponentially it's grown. Has it doubled? Or has it done something else? And so it's a really good tangible way, and I'll show a video in a few minutes, of students who really struggle in math, and this makes it real for them. I think that's probably my biggest win as a math teacher, to see that connection. The contracts are something that I think we struggled with in the beginning. It took a couple times for failure to happen, for kids to say, what exactly am I creating? What exactly is this contract? It's a really simple way to, what I was kind of told by another computer scientist, was write pseudocode. So I guess when computer programmers build extensive programming and they're trying to debug and figure out why their program's not working, they might write out the code in English and have this whole script to the side and see, well, where's there a mistake happening? And as they write it out in English, they'll see, oh, right here, it's as plain as day. And so this is a way for code.org to kind of put it in simple English. We are taking a 60 pixel solid red, star, and we're creating an image out of it, but we're naming the contract star. So we can use this contract if we want 100 stars in the sky in our program. We now just repeat star 100 times, depending on, obviously, if we want them all the same size. So there's a link right here that takes you to the lesson overview for this particular one, writing a contract. And you'll see for a moment, it's, coming back to domain and range, which they've covered previous. This is an unplugged that's about 5, maybe 6 lessons in. And it gives you what students are going to do, what we're going to connect to, what the vocabulary is. And then as you scroll down, this is something really nice. You're going to see a lesson slide deck for the teacher. Now, I did kind of in the beginning go and give this to students, because you can come through and say, this is a contract, PowerPoint or Google Slides presentation for you that you can go back and see, what am I doing in a step-by-step mode? And for some students, this really made sense for them, because I would explain it one time, I might show it one time, but then they have this to go back to and say, oh, this is what I didn't quite understand. This is the notes portion of it.
Just to jump in, that this is just another example of how those unplugged lessons are so important, to have kids take a step back and not just, throw blocks into the formula, and really take a step back and get the vocabulary right and understand that the contracts are a great way for them to just literally understand what is happening when they're putting those blocks together.
Yeah. And I had a couple students, even after their activity didn't work, go back to these these slide decks, or go back to their contracts and really see, well, where did I go wrong? Because as you'll see at the end, you're going to have, 15, 16 different contracts written to make your game work, is the end result that we're shooting for. So, so use some of these tools that are listed in here, the contract log, the slide deck, and then what's in a function, as I showed you on the other one. And then when you get down to the activity portion of it, it really walks you through what you're doing. What kind of math are we using for our number sequence? What kind of styles are we looking for in our images? What is going into making the image? Notice that we have number, string here, but we have number, image to make a rotate. So we might drag this triangle inside the rotate because we want the triangle to rotate. So the contract is about rotating, not about the triangle, but any shape that you would put in there. And again, just coming back to variables every time. So they give lesson tips, and then the evaluation blocks kind of come in here, where they start maybe rolling out what will be the next lesson, and then the wrap up. So if you kind of really do take your time in going through these lessons and understanding how they're laid out, one does really strongly build upon the next. The design recipe is another way for you to kind of write pseudocode a little bit. If we could have a back and forth conversation, this might be a question that some of you will have, but in looking at the design recipe and just this particular worksheet, think about ways that you would use this in your math class. Could you see, proposing a word problem and giving them a sheet like this and using your X's and Y's? We want to buy a certain amount of cookies for a bake sale, and we want to have all these different components of it, X, Y, A, B, C. We really can use these contracts and design recipes to create functions. If the function is a cookie, what goes into making a cookie? What are the dollar amounts? What kind of profit are you going to make out of it? And that's one of the examples that code.org does use in the algebra section, is they have to write code for for a profit loss kind of thing. And then this is just a simpler way to look at the design recipe and the contract. So you're going to name it rocket height. It's going to, produce a domain of seconds and a range as well. But here's the word problem. Given a number in seconds, return the height of a rocket traveling at 15 meters per second. So they really have to think about, what is the rocket doing? How do I make it happen? And then, over here would be the area where you'd see, where you'd see the rocket moving. And is it moving at the pace you want it to? And if not, you have to go back and debug it. And then you'll see one step further, this is the contract for this one, but then they're giving you examples. So now you can take that sort of variable idea and say, okay, I want the size to be 100, green to be my color, but what is happening with the size? What's happening with the radius? Well, we're cutting it in half to make something else. We've got a solid white circle, okay, and there's an overlay going on here. There's a contract going on that talks about an overlay, and then we've got these two kind of submitting as well. And you can test it out to see if it works. So it's a step-by-step process to see if your function is actually working and applying to the definition. And then you can see the definition stage. Does this function with the two variables, size and color, will it work now? Because before we had a number in at size and we had a real color in here, but now these become variables. When we go to the evaluate, you can see that square circle now has two variables that I could change at any given time based on the fact that I put them in here as variables in my definition. So now this 350 could be 500, it could be 5, whatever I want to do. And then they allow you to edit as well, to go back into the definition if needed, to debug it. So you can see how it's that step-by-step approach that Algebra uses, but it's delineated in different ways using examples, definitions, and evaluations. And then you'll see the final product. As you get through all 20 sequences, you're going to work up to what's called the big game. They use the design recipe and function contracts to build this game. And each one of these, the title, the target, the update target, are all just contracts, each with an editing function to be able to go in and define it how you will. And if this were moving, you would see that my ghost would be moving back and forth, and my tennis players would be moving, and there might be a ball where they're trying to hit the ghost. And you set that all up based on colliding and not moving off the screen. So.
And how long does it take, just so people get a sense of how this is the last thing? Mm-hmm. And it takes what, 20
hours, 20 lessons. Yeah, it's we did this, I created this big game in the summer during the training. So it was we were probably in the training for about 10 to 15 hours. So it, seems easy enough when you think about it, but all that work that goes into it. Once you're through it, you really do understand how to then kind of jump into what you'll be talking about next, Alicia, which is the other components of this. So I'll turn it over, and Alicia Kostecki teaches in our computer lab, and she does quite a few things that are extensions of this.
Yeah, so I look at the CS Algebra as just a great, I would look at it from two ways. One is, as a computer teacher, how can I help the algebra teacher? And then on the other side, how can the algebra teacher help me? So looking at it from the perspective of wanting to have collaboration between teachers, and also we all want to have lessons that are multidisciplinary. So this is just a great avenue for that. So again, kind of going back, to have the whole point here being that instead of math being just a bunch of numbers on paper, trying to make it real for students. I think that you'll see in a sec when the students talk how much that means to them, like to have something tangible and something meaningful happening with their math is really important. So I've been doing game design for a while, and having the CS Algebra knowledge has really helped me understand how that connects to the math curriculum, and also has help me understand how the math teacher can help me, like I said. So one of the things I've done for a few years is having students make games in Scratch. And these are, it's a really similar environment to the code.org environment in terms of being blocks that you snap together. It's sometimes I go back and forth whether it's more simple or more complicated for students. But the kids that are doing CS Algebra have already done Scratch, and they do them together. So they seem to be able to make that connection. So besides just like having an extension possibly for students that finish CS Algebra first, but also doing it in tandem. Some of the same concepts are being covered. Things like the coordinate plane, geometry, using variables, using probability. The students in my class definitely use the Boolean logic and conditionals and looping and things like that. So it's a great way, again, for, it's having the CS4All algebra has really helped me understand how I should approach that with the students, things that they already know or things that they need covered. I talked to math teachers who are like, please help me with coordinate plane. Well, Scratch is a great way to do that. Often I kind of assume that students know some of the things, and they don't. Like, even if it's just rotating or simple coordinate plane issues, something like Scratch can be really helpful. Just recently, I've also started doing it in Minecraft. And if you know Minecraft at all, it's just a 3D world where students can build whatever they want with these blocks. But it actually has some really interesting math possibilities. There's even a programming aspect. There's a mod for Minecraft called Computercraft. And so you have the picture of these little turtles, and you basically have that turtle move through space. So just like you have, I don't know, in CS Algebra or in Scratch and Tinker, it's 2D, but this is obviously 3D, but it's the same concept. You have coordinates, you have sequence, you have measurement. I know a teacher that wants me to help him use it for surface area, getting kids to understand those mathematical concepts and how they actually apply in something that they can actually understand because they're so familiar with it.
Mm-hmm. And they just seem to really, they're so engaged. You turn the computer on and you build a game or you get on Minecraft, you immediately have their hooked kind of attention, and they almost don't even know they're doing math.
Yeah, because that's the complaint you hear from students most. Why do I need to learn this? How does this apply to my life? And yes, it's a video game, but that's part of their life and they understand it. So it makes a very powerful example.
Mm-hmm. So we're going to show you a video right now of two students. They're students of mine who, I'm going to pause for a second, sorry. They're two students of mine that this was the first class I pushed into, and it's students who pretty much did not like math, I guess is the best way I can put it. And when I came in saying, well, I was a math teacher in my previous life, and I'm going to come in and we're going to do some things with CS Algebra, they all pretty much wanted to boo me out of the room. A couple weeks later, fast forward, and I have a group of students in this class, predominantly females, weirdly enough, that have pretty much begged me to come back every day. And they're just doing an amazing job with CS4 Algebra. So I'll give them a chance to talk, and hopefully you'll be able to hear it. If not, we can come back and watch it another time.
My name is Alicia. I am from Africa. I'm born in America. My family is from Africa. And I'm an 8th grade salsa class. My name is Akira Beauclair. My family is from Jamaica and Cuban, but I'm from here. I'm an 8th grade salsa class.
And can you tell us a little bit about what you're learning in computer science and what you like about it?
What we're learning is how to put algebra into games and create stuff, and I like it because it's not you sit down and doing equations and stuff like that. You're doing that, but it's a fun way because you can see what the outcome is. It was with she said when you code, it's you use mental math, which is use mental math in a real life situation. So you plug it into a computer or a game and see how it will come out. You're happy you passed the level, achievements.
Absolutely. How do you find that this is different than the regular way you have learned in the past? And is it better or worse? Tell us a little bit about your history here.
Way better.
We'll end it right there. Obviously, she said way better. So, these are two students who now not only are engaged in math and want to become computer scientists, but their whole demeanor has changed in school. And, I've only known them since October. I guess Alicia could talk a little bit more about having known these students probably their whole life.
For a while,
yeah. Is there anything that you've seen that's changed in their behaviors at all?
I mean, these are girls that just need something practical. They are the kind of student, like I said, that wants to know, well, why do I need to learn this? They're busy. They have things to do, and they don't want to waste their time. So they like things that they can see a practical use for. We know this, and sometimes we forget that students want to know why they're learning something, not just how to solve for X.
Mm-hmm. Yeah, absolutely. So in kind of covering, the why we do this, how it's laid out, you're going to obviously get much more into depth about how to plan it and use it when you attend the summer sessions. But the implementation, I think, is the question for a lot of administration, a lot of teachers who are thinking they're going to be teaching this next year. It's designed to be a 20-hour course. Recently, they've broken it up into Part A and Part B, which are each 10 hours long. Again, depending on kind of your answers to these following questions, how will this be taught by every math teacher, or will the tech coordinator be teaching this? Is it in a centralized location in the lab? That's going to determine how fast you're going to move through this course and how collaborative, will you be? So if the technology coordinator is teaching it, then, will she be collaborating with the math teacher, he or she? I think that's essential, and either way works, whether it's the math teacher teaching it or it's a centralized location. I think that,
or it could be a combination, I think.
yeah, absolutely. I think just having that conversation and planning this summer is important. How often are you going to teach it? Here at Disney, we have a kind of laid out schedule that one of our assistant principals laid out, so people know, okay, I'm going to have kids on code.org for a certain amount of time every week, and we've laid a nice foundation here. But with the CS and Algebra, they did not have a foundation when I came over, and we've had to navigate through it. And I have to say, it's been nice to be able to push in, but I also could see how it could really work well if a tech co was teaching it or a computer lab teacher was teaching it. So those are discussions. Obviously, I think that the summer implementation schedule will be, prepared over the summer. This is an area that obviously we've all been kind of talking about is how do we get the ongoing support? Code.org provides many, many opportunities for professional development, not only with webinars and PLCs that they have set up. You can see in the Get Connected section, you can buddy up. We've reached out here at Disney and had a lot of people from outside who are computer science, whether they're in school right now or they're professionals, come and just kind of watch us teach it and be able to kind of insert their knowledge, maybe speak a little bit about what they do to the students to make it more real. There's lots of things on that code.org website that can provide lots of other engaging tools for you. And recently, I've been using Google Classroom quite a bit. So I decided to, not only for my students that I'm teaching to, I've put a lot of things on their own Google Classroom, but I created a Google Classroom for us as teachers who are navigating uncharted territories. So the join code, if you are familiar with Google Classroom and want to join, is right here, CDVN2N. And we've been putting a lot of resources on there as much as we can. I'm assuming that we'll start really getting some good conversations on there as well. I'm going to click on the code.org links and just show you all the different things that they provide. You can see the overviews and the different areas that you can go into, but the online community here and all of the different areas that you can get support. These are excellent opportunities. And then there's leadership opportunities to become a partner or a code.org facilitator. Community resources that you can see, the CSTA. I get updates all the time, and that's from more of a high school standpoint, but it's really nice to think about what we're getting our kids ready for.
Well, I think they're trying to branch down.
Yeah.
So they're trying to do K-12.
Yeah, absolutely. And San Francisco Unified and some other districts are really doing a nice job of thinking about not only the robotics and the connections with, where do we go next beyond blocks, and just kind of being involved in that conversation has helped me connect to this as well. Here's a little bit of information about the summer professional development. As you can see in the CS and Algebra, there's a layout of phase 1. We're doing our online introduction a little bit here, but then, what does phase 2 and phase 3 look like? A lot of it is online, and then there's a couple of, times that you do need to meet in person, and those are valuable because you get to sit next to, like we were talking about that pair programming, you get to sit next to somebody and really get that help from them. So I know that this will be sent out to everyone. This is also a clickable link as well to take you to the Google Doc that lays out all the different summer opportunities for everybody. So setting up your class in code.org. The video for how to set up your class is right here. I wasn't sure if Andy Rasmussen, is he going to play this video or am I going to play it?
Jeanette,
Okay. Wonderful.
Hi, my name is Alice Steinglass. I run the product and engineering teams here at code.org, and today I'm going to show you how to set up your very first class. Now, when you come to the code.org homepage, you'll want to sign in. You guys have clearly already signed in because you're taking the professional development. If you haven't, once you've signed in, you'll see that your name is up here in the upper right. If you click on that, the very first link is the teacher homepage. Now, that's going to get you to everything you need to go to do all of the teacher features on the site. This is all the stuff that the students don't need access to, but you do. Now, the very first link up here on the top left is, or the very first block, is this teacher student accounts and progress section. That's where you're going to go to set up your first class. Now, when you get here, you can see all of the classes you've already set up. In this case, I've set up period 1, period 2, period 3. Let's create a new section together. I'm going to click on this new section button and type the name of my class. Doesn't matter what you call it anything that's useful for you to remember. Miss Fillmore's class, the name of the period, the name of the students, doesn't matter. Let's call this period 7. Now you can choose the login type. For older students, you're going to pick an email. For younger students, you pick a word. And if the kids don't even know how to type a word yet, pick a picture. In this case, I've got a class of first graders, so we're going to use picture logins. They're first graders, so let's pick the grade. And then you can pick the class. Later in this same PD, you'll learn about the different classes and why you would choose one versus another. In this case, for my class of first graders, I'm going to choose course 1. Let's save that. And now I can see that I've set up this class, and let's go into it to manage the students in it. I can add students one at a time, but because I'm setting this class up for the first time, it's a lot faster if I add them all at once with add multiple students. Now I can type the names of my students: Orlando, Maria J. I've got 2 Marias in my class, so the other one is Maria L. We have Kim in our class, or you can just copy and paste them from another list that you have. Hit done, and we've got all of our students here. Now I can enter their ages for them, especially because they're young, or you can let them go ahead and type their own ages in the first time they log in. And I can also enter their genders for them here. Let's put Maria is a female and Orlando is male. I'm going to go ahead and hit save all, and that's it. I've set up the class. All the students are ready to go. Now the question is how they're going to log in. As you can see, we used picture password. So each of the students has their own little picture that they need to pick. Now I need to let them all know what those pictures are. So if you look down here at the bottom of the page, I can print out cards with my students' login information. Before the class starts, go ahead and click here, print this out, cut them out, and give them to each student in the class. That way, when they go to log in, they'll each have their own little card, say Maria's card here, with the ghost, so that she knows the ghost is her login. Now, the other question is where they go to log in. Rather than send them to the code.org homepage, what we've done is created a special section code, special URL, just for this class. So when your students log in, they can go right here, and they'll go straight to the login for their class and let them pick their own picture. Now, we'll show you how that works in the next video. Before we go on, I just want to give you a tip, which is you can go ahead and bookmark this page on the computers, and that'll make it a little easier, especially for younger students to log in. So rather than have to type in this URL, they can just go directly to the bookmark. Thanks.
All right, so that ends our presentation. Like I said, we'll be doing a lot more training and things in the summertime, but we'll turn it over to everybody for questions. Or Charnel.
No, we're going to open it up by just participants. You have participant tile, and you can unmute yourself just by clicking on the microphone. Okay, so now's the time to ask Jeanette and Alicia any questions that you have about CS and algebra. So unmute your phones, your telephone, or either your mic on your computer by hovering over the participant tile. Anybody have any questions? And if you don't want to speak out loud and say your question, you can actually type it into the text bubble here over to your right-hand side of the screen. You can click on that little text bubble and then down below type your question. So does anybody have any questions? So to get you started, again, anybody have any pressing questions? You want to unmute your phone or your participant tile and ask the question. Ask any question you have about CS and Algebra to Jeanette and Alicia. Okay. Anybody?
Anybody, any questions about implementation at all? Does anybody have any thoughts about?
Here we have one.
Okay, here we have one. It says, Elena Zivko, are there algebra word problems that code.org has to offer to apply the design recipe?
Yes. Hello, Elena. There's quite a few that they offer in this course particularly. And a lot of them do kind of build up to that big game. So like I mentioned before, there's a couple of them that talk about cookie sales and bake sales and, talking about creating a contract for profit or cost. I really like that one that they give. But I think, for those math teachers out there and people who are trying to extend, there's definitely ways that I could see extending with word problems using the design recipe and the contract. So if you just came up with your own problem, maybe you have students come up with a problem and they use that contract or that design recipe to create something. Maybe you could even turn it into a scratch. So great question. Thank you.
So I have a question while we're still waiting for any additional questions anybody might have. Please unmute your phones. This is an interactive webinar. We want to hear your questions. Here's another one. Great. We have it from Kathy. She says, I did a course 1 in science, and then the science teacher continued the same with math. That way, I do the groundwork in coding, and they do the subject area.
Yeah, Kathy, I did something really similar with science here at Disney, where I did the module 1 for the project guts, and then the rest of the modules were done by the science teachers or the homeroom teachers that teach science. So I could see something similar with CS Algebra for sure.
Mm-hmm. Yeah, and it's depending again on how you're going to roll this out. I felt as if the science one could connect really well to almost any content that you're doing in science because you build these models and you can do simulations with them. Mm-hmm. Whereas this algebra one is particular to building a big game, and it's pretty focused in that. But I think they both work really well together. And science was actually a little more complicated for me. Maybe it's because I'm generally a math teacher, but
it's a more complicated.
Yeah, programming. Yeah. But yes, I think that just building that groundwork and then kind of having that collaborative piece where everybody shares out in the challenges is a great way to do it.
So great question, Elena and Kathy. Are there any additional questions, please? This is a webinar that was designed to support your efforts. And I think we saw another question. I'm not sure. She said the Star Logo Nova is much different than what you're doing in your environment. Can you talk about that?
Mm-hmm. Yeah, well, the Star Logo Nova, it does not, it has codes provided modules that do have lesson plans to follow and everything. So they set you up very nicely. But in CS Algebra, the students have an environment that they are working through step by step. The girls talk a little about that. It gives you feedback, like you have these puzzles to solve that are basically activities preparing you to do parts of your big game over the course of the weeks. Whereas Star Logo Nova is, more open-ended in a sense, mm-hmm. Where you learn to use the software to program the little agents, but then each module after that is its own separate thing and can be done completely independently, mm-hmm. Probably for different grade levels even.
Yeah. And there's one of the links that I showed, I probably didn't scroll down far enough. I think it was the third link that I showed on the code.org website, compares what Star Nova logo was like in comparison to what now, they're doing. And what the differences are. So there is that support on the code.org website.
So Jeanette and Alicia, I have a question while we're waiting for additional questions for somebody to unmute their phone or either text a question here. What about the alignment to your math curriculum in your school? How did you guys, and how did you approach that initially to work with the algebra teacher and tech coordinators, tech liaison, and actually target that to your curriculum and do that alignment?
Yeah, I guess I started particularly, we've got, one math teacher who teaches 2 sections, and in sitting down with her, looking at her lesson plans and understanding where she was at, like I said, I entered here in October, and she was just getting into slope in November. And I thought, well, this is a great opportunity to kind of reinforce some of the vocabulary, some of the concepts that they were doing in slope, but to kind of enter in with the CS and algebra. And so what we said we would do is, once a week, for an hour, I would push in and kind of support what they had been doing the other 4 days and really tie it in. So she'd need to share with me all the activities they were doing for that week so that I could look at it and then align, what we were doing in CS and algebra so that I could talk. I wouldn't necessarily jump ahead to lessons. What I would do is when I talk about lesson 1, I would try to make those connections. Like Alicia was saying, she's getting this understanding of what's going on, not only in math, but with what I'm doing. And then she even builds upon it more with Minecraft and Scratch. So the essential thing is that collaborative piece. What have you been doing before I walked in the door? And like I said, with having the standards aligned right there on the page in the lessons, it's so easy to lay your lessons out and say, I see where this can match up. And we will get to slope in the 3rd lesson. And so you're building that in time-wise. I don't think it needs to, some teachers have said, I don't have time for this, but you do, because you're going to teach it anyway. It's just a different way to unfold the same standards. And it's a more engaging way to unfold those standards for some students, as you see.
So what differences? Oh, we have another question. And that is actually from Dolores. And she says, one lesson seems to build upon the next. How would you suggest that an algebra teacher differentiate instruction for 6th, 7th, and 8th grade classes for the 1st and 2nd year?
That's an excellent question. Yeah. And I really like exact same question I had when I came here. I thought, well, then what am I going to do with my next year's class who had already had it? And I think this is a conversation when you do your summer planning. Are you going to do all of the 20-hour course? Or are you going to just do part A? Or are you going to maybe supplement with some of the things we talked about with Minecraft or Scratch or robotics? There's a lot of connections that I could see where I could stop doing what I'm doing and jump in and talk about measurement and functions with lots of different things. So, unfortunately, there's not like a yes or no answer, to this question, but I think you have to sit down and say, for your 6th grade, what are you hoping they accomplish in math? But also, how does that tie in? What does it look like in CS and algebra? Or is it a combination of course 4 and CS and algebra, or CS and algebra and maybe a little bit of something else that code.org offers?
I was just going to say that there's some other things in code.org that could be used for that, just instead of going to something like Scratch or something off.
And remember, this is about exposure. I think as we're entering into uncharted territories, thinking about how this aligns, the main goal that I had was to expose students to the ideas of this is a possibility for a career. This is how math does become real. And, even if you decide to do it for a semester or a quarter, I think that exposure is essential because students will. We, in a few minutes here, are doing a girls coding camp for 2 hours. And it's really great to see 20, middle school students staying from 5 to 7 at school because they're interested in computer science now. So it's that generation of activity and that excitement. So you do have to think about, if you roll it out in year 1, what are you going to do year 2? You might have to do something different.
So we look here at Kathy Chacon. She has a statement. She said, we ended our unit with programming robotic finches borrowed free from the library. How about that?
Excellent. Yes, that's something I want to try. I might have to call you and ask you about that.
All right, any other questions? Can you talk about how students are learning differently while we're waiting for any additional questions? How are students learning? And you know, computer science programming is only one aspect of computational thinking, computer science. So that inquiry-based learning, that's in terms of how do you see students learning differently, and how do you see them developing more of a conceptual understanding of the mathematical concepts using CS and algebra?
You know, it's funny because right before we got on this webinar, Alicia and I were talking about teaching a long time ago. We won't say how long we've been teaching, but you know, there used to be this whole way you taught that was very hands-on, project-based learning. My math class 10 years ago, we would be, you know, we'd have basketballs and bananas and all sorts of things all over the place. We'd be like measuring them and trying to figure out surface area and circumference. I mean, it's crazy the things we had. You know, the reason I give those two differences is because we literally would measure everything. And then we did a unit where we build basketball courts for March Madness and talk about scale factor and proportions. All we're doing now is we're saying that computers now design just like hands do. Okay, we're building something. We're building a program that moves things. We're building a program that, you know, is useful for gaming. We're building a program that makes our lives easier. And I think it just goes back to simple project-based learning, and, you know, moving away from this content-driven sort of world that we've lived in the last couple of years. I really like that computer science is bringing back the hands-on learning, the kinesthetic learning that students want. They're getting out of, and, you know, Kathy can probably say this, when you're programming robotic finches, the kids are getting out of their seats, there's movement happening, and they're problem solving in teams. Sometimes they're having to use a whole team of people to figure out a problem, and that's the number one thing employers want.
Yeah, and it's not only the computational thinking, but also the computational practices. You know, whether it be just, you know, learning from failure, like all those design process things that we want to encourage in our students. You know, trying, debugging, seeing what happens, trying again, getting ideas from your neighbor. You know, those are all practices of computer scientists and people in the real world. So it's not you're just with your own worksheet in front of you. So it's how it's being taught, not just what is being taught.
So I just want to make a statement here. We do have a question, and I'll come to that question in just 1 minute. But I just want to, if you can move to the next slide.
Move to the next one, sure.
Okay. I just want everyone to know that there is this webinar is being repeated on Monday, April 11th from 4:15 to 5:15. And today's Learning Hub number, as you can see, for April 6th from 4 to 5 is 63680. So if you want those in terms of your CPDUs, the Learning Hub number is here. And then for Monday, of course, it's there as well. Now, this is going to be repeated, and you can certainly join in again, but please feel free. I just want you to let you know you can spread the word there. And also, one last thing, I just want to repeat this again. This CS and Algebra Bootstrap webinar does not take the place of any CS4All required online summer or semester CS and Algebra training for teachers. It is purely for informational sake, and it's not intended to actually take the place of any required training. So with that said, let's go to this question, and I think that'll actually be our last question. And Kathy says, we ended our unit, yes, this is Kathy responding. She says, yes, they love it. And you see those aha moments. So you guys want to talk about those aha moments? Have you had any of those?
So many. You know, I have one of the best jobs. I get to walk around with robots and make connections. Kids love what they're doing, and you see them reading, close reading strategies. I mean, in 1 hour session of robotics, I can have them doing literacy, math, science inquiry processing. I can have them, you know, really kind of digging in with, you know, collaborative ideas and environments. You're really hitting on all cylinders rather than just one or two. And it's that interdisciplinary learning that gets exciting for me as a teacher, but just to watch the kids smile and have some fun with it is, you know, what we all want for our kids.
I like to see the transition from being super, super excited to be designing and programming a video game to then getting frustrated and realizing you have to actually work at it, but then also getting through that and be like, hey, I finished, I made a video game and it works and my friends can play it. So, and it's a really cool experience.
Yeah.
So I want to thank everybody for attending today's webinar. And I want to go back to thanking also Alicia and Jeanette for taking the time out of your busy schedule, and participants online for taking the time out of your very long, busy day to actually join in this webinar, and for them to facilitate it. It's been awesome. So any closing thoughts, Jeanette and Alicia, before you
Just go to the summer PD. It's fantastic, and keep learning.
right? And I think we just have a thank you. Thank you.
Thank you.
Elena, thank you for facilitating this webinar, and thank everyone for joining us online. And please come back again Monday, April 11th from 4:15 to 5:15. Jeanette and Alicia will be repeating the CS and Algebra Bootstrap webinar. Thank you everyone for attending. Wait a minute, we have one more. Oh, Margaret says, thank you, I learned a lot.
You are welcome.
Thank you, Margaret, and thank everybody else online for joining us today, and we'll see you on Monday.
Thank you. Bye-bye.
Bye-bye.